Okay, we're going to start with a brief review of the concept where you take the log of both sides to solve, and that's also going to be useful for today's lesson, so I'm just going to start with a couple of these and show you how to do them. So the first thing I'm going to do is isolate the power, and for ones like number 1 here, it's already isolated, so you can go right in and take the log of both sides. So I'm going to go to some that are a little bit more complicated. Let's look at number 3 here. And if you look at number 3, the power itself is this 6 to the 3n. So I have to get that all by itself. So I'll divide both sides by 5. And I will end up with 6 to the 3m is equal to 4. And at this point, I can now take the log of both sides. Log here. And then I can bring the 3m out front using my property of logs, and then that turns it into multiplication. So I have 3m times the log of 6 is equal to the log of 4. And remember that the log of 4 is just a number the calculator will give you. The log of 6 is just a number the calculator will give you. So I'm going to now divide both sides by 3 and by log of 6. So I've isolated m. So divide by 3 and divide by log of 6. Now, if you're going to do this in the calculator, you can just do it in 2 steps, or you can do it all in 1 step by using the parentheses like I did there. So let me just show you that real quick. So I will have log of 4 and divide by, make sure to close the parentheses, and then divide by, and then use parentheses so that it knows I'm multiplying the 3 times the log of 6. And you don't actually need that little multiplication symbol there, but it works either way. So I have opened this parentheses. I need to also close it right here. So I'm going to close it, and then there's my answer, 0.258. Now, if I did this in 2 steps, I just want to show you get the same answer. So log of 4, and I could first divide that by 3, and then divide that by the log of 6. So if you do it in 2 steps, you're still going to get 0.258. So that would be your answer, 0.258. So that is how you do one like that. Now let's go to one that's a little bit more complicated, and that might be one where you have like addition and subtraction first and then division. So let's look at number 13 down here, and you can pause and write this down so that you can kind of work it with me here. So when I look at this, I see my power is 6 to the p plus 6. And you don't realize how important it is to know that that's your power because you want to isolate that. So the first thing I'm going to do is I'm going to subtract this 4 from both sides. And then I end up with a negative 2 on the right-hand side there. Then I'm just going to bring down everything that's left. Negative 4 is being multiplied by 6 to the p plus 6. And I'm going to get rid of this multiplication using division by negative 4. So I end up with 6 to the p plus 6 is equal to a positive 1/2, because that will simplify down. At this point is when I can take the log of both sides, so log here, and then bring down the entire exponent. So p plus 6, and be sure to put it in parentheses because it reminds you that the log of 6 is really being multiplied by both of those. You don't actually have to do the multiplication though, but just make sure you use parentheses. Now, so I have p plus 6 times the log of 6 is equal to log of 1/2. I'm just going to simply divide both sides by log of 6. And I'll get a value when I do that. And you can see all I have left over here is p plus 6. So then I will subtract 6 to get my final answer. So it's going to be, on the calculator, kind of follow along, log of 1/2. You can do this all right here in the calculator. And divide that by log of 6. And be sure every time you do log that you close the parentheses. That's really important. And then I'll get that value, and then I will just subtract 6. So the answer will be negative 6.39. So negative 6.39. So a few of you had asked to see some more of those, so I went ahead and did that. Now, going to the notes for today, like I said, we already started this in class, but I want to give you some notes on this. And you guys, we talked about this in class. You have your starting amount. You have your ending amount. You have your growth multiplier or decay multiplier. So it would be either 1 plus R or 1 minus R for decay. And then, of course, you have your X value, which is going to be your number of growth or decay cycles. So number of cycles. And we talked about this in class as well. And then we also have our compound interest formula. So this is when you see the word compound in your given information, you're going to want to use this formula. And the main thing to remember is you have to use N, and N is the number of compounding periods per year. Number compound periods per year. And then, of course, you have to adjust the formula. So you're going to be given the formula, so don't worry about that. So let's kind of do a few more like we did in class today. You start with 100 fruit flies. The population doubles. So this is a doubling scenario. We talked about this in class as well. And that means I'll have time divided by my double time. And I'll kind of show you what that means. So how many fruit flies will there be after 6 weeks? So you start with 100 fruit flies. They double, and it doubles every week. So how many do you have after 6 weeks? So it's 6 over 1. And of course, you don't really need the 6 over 1, but I show you that just so you'll know how to do it next time. So in the calculator, it's just going to be 100. And obviously you'd have a calculator on this part, raised to the 6th power, and that gives us 6,400. So that is the type of problem we worked on today. So let's do another one. The population of a school is currently 1550. The population is decreasing by 8% each year. How many students will there be in 10 years? So this is a decay problem. So I start with 1550. 1 minus my decay rate. Remember, you need to put it in decimal form always. And then 10 is my exponent. Okay, so we'll just do this in the calculator. So 1,550, and then 1 minus 0.08, because I'm losing 8% each year, and it's going to decay for 10 years. So I'm going to enter that, and I get 673. We'll just round to the nearest whole number for that. So 673. So that's how many students we would have. Also think about it from a logical perspective. If you know your population is decreasing, if you start with 1550, you know you should have fewer than that 10 years later. Okay? Now let's do the next one because it involves the other formula. So John invests $2,500. That is the interest rate compounded quarterly. That means N is 4, and that's really important. So my amount is going to be equal to my starting amount, $2,500, 1 plus my rate in decimal form, divide by 4, and raise to the 4 times, and time is 10 years. So we're just going to plug all this into the calculator all at one time. So I have 2,500. I have 1 plus 0.05 divided by 4, and then all that is going to be raised to the 4 times 10. And I can just put it, I know that's 40, but I'm just showing you what it would look like. And then press enter, and you get 4,109. So 4,109. And let's go ahead and give it, I don't remember exactly what it was, 0.05. All right, so $0.05. So that's kind of what we've done in the past. And all we're adding today is now we can solve for the time using our logs. So it's very, very similar to what we've been doing. You'll see in a minute how it is a little bit different. So you start with 25 fruit flies. The population doubles. So I kind of know what I have so far. So I'm starting with 25. I have a doubling scenario. And I want to know how long it will take for there to be 880 fruit flies. So I'm solving for this x right there, and I'm going to end up with 880. Now, how do I do this? Well, now it is just a regular log solving problem like we did over the past couple of days. I want to isolate the power. The power is 2 to the x. So I'm going to divide both sides by 25. Okay, so I end up with 2 to the x. I'll just write it over here. 2 to the x is equal to 880 divided by 25. Now, I would take the log of both sides at this point. So put a log here, and just put this in parentheses. And then the x will come out front. So I have x times log of 2 is equal to log of 880 divided by 25. So to solve for this x right here, I only need to divide by log of 2. So all this gets divided by log of 2. So let's do that in the calculator, and I'll kind of show you. And like I always say, the calculator's pretty much half the battle. So I will have log, and I'm going to do it all at one time, 880 divided by 25, close the parentheses, and then divide by log of 2. And that is going to give me 5.14. So that is the number of time periods. So let's kind of go back and look at what that means. So it's the number of time periods. So it's going to be a little bit more than 5 weeks. I'll put approximately 5. I can't remember exactly what that said. It said 5.14. So 5.14 weeks. So that is what we're doing today. So it's nothing too terribly different than what we've been doing. It's just bringing two things that you know how to do together into one. And let's do the next one. The population of a town is 12,500. If the town is growing at a rate of 3% per year, how long will it take for the town to reach 18,000? So I'm going to end up with 18,000 people, starting with 12,500. And it's growing, meaning I need 1 plus my rate. And then how long? So again, I'm solving for that x. So again, I have to isolate my power. This is my power right here. So I'm going to start by dividing both sides by 12,500. So I'm getting rid of that. So then I'll kind of just tidy it up a little bit. 1.03 to the x is equal to 18,000 divided by 12,500. Now I can take the log of both sides. That's our goal here. So I'm going to take the log over here, and don't forget you're just going to put that in parentheses. And then the x will come down front when I take the log over here. So I'll kind of just combine that step. So this x is now gone. Now to solve, I'm just going to divide by log of 1.03. So log of 1.03. Now, you don't want to like combine these logs in any way. You want to get the log of the numerator and then get the log here in the denominator. So these will cancel. So it's going to be log of 18,000 and then divide that, 18,000 divided by, like that. So, and then I would divide that by the log of 1.03. And I get 12.34. So 12.34. Now, and the rate is given in years, so this will also be given in years here. So same way for number 1 up here, the population was doubling every week, so I'm solving for x, and x will be in terms of weeks. Okay, the final one here. John invests 500, and it's compounded monthly, so n is 12. How long will it take for John to have 3,000 in his account? So I'm going to just use my formula, the upper right one up here, and I'm going to say he ends up with 3,000. He's starting with 500. 1 plus 0.035 divide by the n of 12 because it's monthly, and then it's 12t. So I'm solving for that unknown number of years right there. This is my power. I need to isolate that. I'm just going to divide both sides by 500. So divide both sides by 500. Okay, so when I do that, I don't actually have to do any of this in the calculator yet. I'll do 1 plus 0.035 divided by 12. All that's my base, is raised to the 12t, and that is going to be equal to 60. All right, so then I'm going to take the log of both sides, just like we've been doing. And, sorry, that should just be a 6 there. So log here and log here. And then the 12t can come out front. So I'm going to have 12t times log of 1 plus 0.035 over 12, like this, is equal to log of 6. And then to solve for this t, it's like one of the ones we did earlier. I'm going to divide by 12, and I'm also going to divide by the log of all of this. So 12 times, remember this is all together. I'm going to show you how I would probably do it. 1 plus 0.035 over 12. And all of that is multiplying the denominator. I probably wouldn't do it that way, but I'll show you how I would do it in the calculator. Okay, so the first thing I'm going to do is I'm going to go ahead and get log of 1 plus 0.035 divided by 12. So like this. And then when I get that value, I can just pull that right back up and multiply by 12. So there's my denominator. So then I'll do the log of 6 and divide that, and then I can pull it back up by doing second answer, recalls the very last answer that you got. So I get 51.27. So that's a long time for him to grow that money, but that's how long it'll take. So it will be 51.27. Sorry about that. And that will be in years. Okay, so on the back, you are going to do 1 through 4 only. You're not doing these about the Richter scale and all that. These are basically very similar to what I just did. Number 4, when I was working the key, it kind of got confusing. It's almost like 2 separate little problems. So you kind of have a part A here, and then you have a part B there. So 1 through 4, and we will check that tomorrow. Y'all have a great day.